Welcome to Get Your FRQ On. This question is from 2000. It is question 6 and it is not calculator active. In the question stem, we have an equation for dy dx, and that's pretty much it. In part A of this question, we are asked to find a solution y equals f of x to the differential equation if we use the initial condition that f of 0 is equal to 1/2. Now, when you have a question like this in a free response question, in the AB course, or at least on the AB exam, the expectation is usually to use separation of variables because aside from separation of variables, AB students typically don't have any other methods for solving differential equations. So if you recognize that a differential equation could be solved using separation of variables, you should go ahead and use it. One, that's probably the expectation. Two, it may be the expectation in the scoring guide for this question, and not using separation of variables may end up costing you points. All right, so we're going to use separation of variables. All right, given the expression for dy dx, we have dy dx is equal to 3x squared over e to the 2y. All right, so setting this up for separation of variables, we get e to the 2y dy equals 3x squared dx. And then we're just going to integrate both sides to get antiderivatives. Integrating both sides, we get 1/2 e to the 2y equals x cubed plus a constant, which I've named c1. And then I guess we can multiply both sides by 2 to clear the fraction, and we get 2x cubed plus a different constant. And the reason I've renamed the constant at this point is c1 was my first constant, and now I've just doubled it. So I don't want to assume that c and c1 are actually the same value, because the second constant is double the first one. So I like to change that to my final c once I know I'm done doing any arithmetic with that constant. So now I have an expression of the form e to the 2y equals 2x cubed plus a constant. Okay. If I take the natural log of both sides, I get 2y equals the natural log of 2x cubed plus that constant, and then I can just multiply both sides by 1/2 and get y equals 1/2 the natural log of 2x cubed plus my constant. All right, so that is the form or the family which this solution belongs to. I do have to make use of that initial condition, though, to actually pin down a specific value for c. All right, so using the initial condition that f of 0 must equal 1/2, all right, plug in 1/2 for y and 0 for x. 1/2 equals 1/2 the natural log of 2 times 0 cubed plus a constant. 0 cubed is 0, 2 times 0 is 0. Canceling out the 1/2s, we get 1 equals the natural log of c, which implies that c is the number e itself. And so our particular solution for this differential equation, using the fact that f of 0 needs to equal 1/2, is going to be y equals f of x equals 1/2 the natural log of 2x cubed plus e, and that will be our particular solution. In part B of this question, we are asked to give the domain and range for the function that we found in part A. Now, because our solution was a logarithmic function, the domain of a logarithmic function is only positive real numbers. So we have to take our expression 2x cubed plus e and make sure that that is greater than 0 so that we can actually take the logarithm of whatever that value happens to be. So this just requires us to write a pretty basic inequality and then solve it. If 2x cubed plus e has to be greater than 0, eventually we get to the point where x has to be greater than the cube root of negative 1/2 e. Now the range, because this is also a logarithmic function, and the range for a logarithmic function is going to be all real numbers, because we're not excluding anything from the domain aside from values where the function just isn't defined. We're not stopping anywhere. So the range here would just be all real numbers, which you can express in a number of different ways, which would probably earn credit. So that's question 6 from the year 2000.